Hello everyone, a part of the AG104 certification series. We are learning the content from Azure documentation. We were looking into configure and manage virtual networks for Azure administrators. We have completed all these chapters and we will be discussing about improve application scalability and resiliency by using Azure Load Balancer. So, identify the features and capabilities of Azure Load Balancer, deploy and configure Azure Load Balancer. Let's go to the introduction. So, identify features and capabilities of Azure Load Balancer, deploy and configure instances of Azure Load Balancer. This is introduction. What is the next thing? We'll go to the second chapter. So, with Azure Load Balancer, you can spread user requests across multiple virtual machines and other services, allowing you to scale the app to larger sizes than single virtual machine. Can support and ensure that users get service even when a machine fails. In your healthcare organization, you can expect large user demand. It's vitally important that each user can book an appointment even during peak demand or when one or more virtual machines fail. If you use virtual multiple servers for your front end and load balancer to distribute traffic among them, you achieve a high capacity because all the virtual servers collaborate to satisfy requests. You also improve resiliency because the load balancer can automatically reroute traffic when virtual service fails. So here you'll learn how load balancer features can help you create robust app architectures. Distribute traffic with Azure Load Balancer. Azure Load Balancer is a service you can use to distribute traffic across multiple virtual machines. Use load balancers to scale applications and create high availability for your virtual machines and services. Load balancer use a hash-based distribution algorithm. By default, a 5-tuple hash is used to map traffic to available servers. The hash is made from the following elements: source IP, source port, destination port, and protocol type. Load balancer supports inbound and outbound scenarios, provides low latency and high throughput, and scales up to millions of applications. Load balancer and physical instances. Load balancer objects are used to express how Azure configures its infrastructure to meet your requirements. With load balancer, you can use availability sets and availability zones to ensure that virtual machines. With load balancer, you can use availability sets and availability zones to ensure that virtual machines are always available. Availability set protections from hardware failures within the data center. Availability zone protection from entire data center failure. Availability set is a logical grouping used to isolate virtual machine resources from each other when they are deployed. Put in availability set runs across multiple servers, computer racks, and storage units, network switches. If there is hardware or software failure, only subset of virtual machine is affected. Your overall solution stays operational, essential for building reliable cloud solutions. Availability zones and availability zones. till this completes, we will go to the next chapter. We were doing exercise, and we'll discuss about internal load balancer. In addition to load balancing requests from users to front-end users, you can use Azure Load Balancer to distribute traffic from front-end servers evenly among back-end servers. Front-end servers called business logic servers hosted in middle tier. You want to ensure that middle tier is scalable and resilient as front-end. So you want to use load balancer for that. This way you can scale out middle tier servers to achieve highest capacity possible. So configure an internal load balancer. When you create load balancer, select internal type value. When you select the setting, the load balancer front-end IP address isn't exposed to the internet. Assign private IP address instead of public IP address. Place the load balancer in protected virtual network that contains virtual machines you want to handle the request. Okay. And the ethical part of the application layer is stateless, so you don't need to use source IP affinity. You can use the default distribution mode of IEEE. This mode offers greater scalability resilience. Let's check the knowledge. Which configuration is required to configure internal load balancer? Virtual machines must be in the same network. Which of the following statements about external load balances? Here they are asking about external. Okay, we have a public IP address. Great. So next our exercise C. It's saying invalid image. That's fine. There is something problem with the script they have provided to us. So we have to create a public IP address, and then we'll create front-end IP, and then we create a backend pool configuration, and then we create a health probe. Then we create a load balancer role. So here this is backend pool, like collection of virtual machines which the load balancer directs traffic. This is a probe. Probe means checking whether the virtual machine is working or not. So it will check on port 80. And load balancer rule. Backend pool and front-end IP will be assigned here. Front-end port is 80, backend port is 80. Probe is the probe. Probe means which probe? Which we created. All the elements here mentioned are the previously created one. And then we will create load balancer based on the front-end IP, backend pool, probe, and load balancer rule. Connect VMs to backend pool by updating the new network interfaces that script created to use backend pool information. So we are connecting them. So we'll get a load balance as IP. So in a new browser, you will paste the load balancer, then try force refresh. It will display other VMs. Yeah, if you stop one VM, it will show the non-stopped VM, means which is a working VM. Okay, let's exercise completed. So internal load balancer we discussed. Summary. So in this module, we learned about Azure Load Balancer. How can you use load balancer to minimize the effects of failures and increase the resilience and stability. So that's it for today. We'll connect in the next lecture. Thanks for watching.